complex analysis, and subtopic is analytic function and its properties. Okay. So first we define what is Jordan curve. A Jordan curve is a simple closed bounded curve divides the complex plane into two domains, where the curve has a common boundary. Okay. Next, you know what is the limit of a complex function. Here, L is the limit of a function if mod of fz less than L, mod of fz minus L less than epsilon, whenever 0 less than mod of z minus z0 less than delta for all z belongs to D. If L exists finitely, then we say that the limit is exist. Okay. Next, what is the differentiability of a function? Here, a limit z tends to z0, fz minus fz0 by z minus z0 exists finitely. Then we say that the function is differentiable at the point z equal to z0. After that, here is a most important theorem or important equations, Cauchy-Riemann equation, that is CR equation. CR equation, it is important for necessary condition that the function fz equal to u plus iv is may be differentiable at the point xi plus ieta is that ux equal to vy and ui is equal to minus vx. And here is a very important example that this example shows that CR equation is not a sufficient condition for differentiability. Okay, so this example is very important. Now the question is, what is the sufficient condition for differentiability? Okay, next theorem is sufficient condition for differentiability. A single value continuous function fz equal to uxy plus ivxy is differentiable in a region R. The partial derivatives ux, uy, vx, vy all are continuous and satisfy CR equation. These two conditions are the
sufficient condition for differentiability.
Okay. Next, what is complex integration? You know what is complex integration, so we skip this. Okay. Next, what is Morera's theorem? F is continuous in a simply connected domain D, and integration over gamma if z dz equal to 0 for every closed rectifier group gamma in D, then F is analytic in D. Actually, this is the reverse of the Cauchy's fundamental theorem. Okay. Next, what is Cauchy's inequality? You know, so this is here, I skip it. What is power series? The series of the form n equal to 0 to infinity a into z minus z0 whole to the power n. This form is a
power series.
And what is the radius of convergent of the power series? We know r equal to 1 by delta, and delta equal to limit n tends to infinity limits supremum nth root of mod of an.
আরেকটা সেই করা যায় সেই 1 প্লাস,
and there is another formula was there. Okay, so here three possibilities. If r equal to 0, this series does not converge for z not equal to z0. Okay, if r is any finite number, that is 0 less than r less than infinity, then here is a circle gamma mod z minus z0 equal to r. There is two parts is there, I gamma and E gamma. I gamma means interior of the circle, E gamma means exterior of the circle. On the interior of the circle, this series
absolutely
convergent. and on the exterior of the circle, the series
does not
converge.
converge.
Okay. Next, residue. Residue. What is residue? You know, the residue. If you expand a function in a Laurent series, then the coefficient of the term 1 by z minus a is the residue of the function at the point z equal to z0.
Z0.
Okay. So we can give an example of residue at the point z equal to z0. Example is residue for the function fz equal to e to the power minus 1 by z. Okay, at the point z equal to 0, then we find out the residue
minus
of
1.
f at the point
Z
0 is
minus 1.
Okay, that is minus 1 is the coefficient of 1 by
1
z.
by z.
Okay, a residue, then we discuss the very important theorem of Cauchy's residue theorem. F is analytic within and on a simple closed rectifiable curve C, except at a finite number of isolated singular points A1, A2, A3, An within C, then integration over gamma fz dz equal to 2 pi I into summation of k equal to 1 to n residue of f ak. Okay, next theorem is, let the function f be analytic in the extended plane within with the exception of a finite number of isolated singular points, including the point at infinity, then summation of k equal to 1 to infinity residue of f ak equal to
0.
Okay. Next, what is argument principle? Argument principle is that let f be analytic within and on a simple closed rectifiable curve C, except for at most a finite number of pole within C, and let fj not equal to 0 on C, then the excess number of zeros over the number of poles of f within C is equal to 1 by 2 pi times the changing the argument of fj. Okay, that is n minus c equal to 1 by 2 pi into argument of fj. Okay, then Cauchy's theorem and fundamental theorem of classical algebra. What is fundamental theorem of classical algebra? Every polynomial of degree n has n zeros in the
Complex plane.
Okay, then maximum modulus theorem. What is the maximum modulus theorem? If f be analytic in a domain D bounded by a closed curve gamma, and let f be continuous on the union D union gamma, m is the maximum value of mod of fz for z belongs to D union gamma, then for every z belongs to D, mod of fz less than capital M, provided f is non-constant in D. Here, most important things is that the maximum value attains on the boundary of the region, boundary of the
Region.
boundary of the domain. And here minimum modulus theorem, just if we include a extra condition is
Fj not equal to 0.
Okay, this is the minimum modulus theorem. Okay. Thank you.